Welcome to the derivative of, I guess, the derivative and motion, derivative of motion. So recall that we saw before that velocity, right, which is essentially speed with a direction, was just an instantaneous rate of change. Of position, right? Or you will often see this as displacement as well. And so what we have essentially is that velocity is just the derivative of position or displacement. So a relationship between displacement, velocity, and acceleration, what we have is if d of t is the displacement function, again, you can also view that as position. It turns out, as we were just discussing, that d prime of t is the velocity function. So again, we're going to so then we'll say v of t is our velocity. Then it turns out that v prime of t is our acceleration. So we can use repeated derivatives to get to acceleration. So the most common form of acceleration that we work with all the time is gravity, right? We are constantly experiencing acceleration due to gravity. If we drop something, it will experience acceleration due to gravity. So gravity acts as, we experience acceleration due to gravity. Change that. So falling objects experience acceleration due to gravity. And at least on Earth, this acceleration due to gravity is either often referred to as negative 9.8 meters per second squared, or in terms of feet, this is negative 32 feet per second squared. So what essentially this means is that as an object falls, its velocity or speed toward the Earth is changing at a rate of 32 feet per second And then negative is implied because the object is falling downward. But basically that velocity, the speed, is changing at 32 feet per second every second. So if the speed is, if you drop an object or throw an object downward and it's starting at say 5 feet per second, well, within a second, you're expecting it to change by about 32 feet per second, maybe go up to around 37 feet per second. So the velocity, the speed is changing by 32 feet per second. So that is, again, just instantaneous rate of change, the derivative, and talking about displacement or position. And then velocity and acceleration come out as derivatives.